Hello, everyone, and welcome back to the Deep Dive.
Great to be here.
Today, we're digging into something really ambitious, the big push to bring advanced computer chip manufacturing back to the United States.
Yeah, it's a massive undertaking, especially focusing on that huge TSMC investment down in Arizona.
Exactly. It touches on everything, economics, jobs, even geopolitics, and it really throws a spotlight on how fragile these global supply chains can be for components that are, well, absolutely essential now.
It really does. The U.S. used to make around 40% of the world's chips back in 1990.
40%. Wow.
Right, and that number dropped to about 10% today. So this isn't just, a company expanding, it's strategic. It's about trying to secure a critical industry.
That really sets the stage.
Yeah.
So TSMC's plan for Arizona sounded huge from the start, like $65 billion for three cutting-edge factories or fabs.
Yeah, making the really advanced stuff 4 nanometer, 3 nanometer, even 2 nanometer chips. The goal was high volume production starting, I think, first half of 2025 for the initial phase.
That was the plan. Seemed simple enough on paper, maybe. Just sort of copy-paste a fab from Taiwan to Arizona.
Well, not quite. As they found out pretty quickly, it ran into what some called a sandstorm of problems.
Okay, so what kind of problems are we talking about? Why is it proving so much harder?
Well, for starters, just building the thing, it takes at least twice as long in Arizona compared to Taiwan.
Twice as long?
Yep. And it costs about 50% more. Big difference.
So right away, delays and cost overruns. What else?
Water. That was a huge one. Arizona isn't exactly known for abundant water, right?
Definitely not.
And making these advanced chips needs incredible amounts of ultra-pure water. We're talking maybe 2,000 gallons for just one silicon wafer.
2,000 gallons for one wafer.
Yeah. So Fab 21 alone, one of the fabs, is projected to use over 4 million gallons a day.
That's staggering.
Yeah.
How did they deal with that?
They basically had to build a whole separate, incredibly sophisticated water purification plant within the plant. Arizona's water has different minerals, a whole different chemistry than Taiwan's.
So it wasn't just building a chip fab, but also a state-of-the-art water treatment facility, one of those invisible factories you mentioned.
Exactly. And then there's the materials supply chain, another invisible factory that wasn't quite there.
Ah, right. So things like chemicals, gases.
Precisely. They wanted to source locally, obviously, but they ran into issues like sulfuric acid from U.S. suppliers was apparently almost 5 times more expensive.
5 times. So what do they do?
They ended up shipping it from Taiwan, over 6,000 miles away.
Okay, that really highlights the supply chain gaps, doesn't it? If you have to ship basic industrial chemicals across the Pacific.
It does. And it wasn't just sulfuric acid. Specialty gases like neon, which you need for the lithography lasers.
The machines that print the circuits.
Yeah. Those gases, even the basic silicon wafers sometimes, are still largely imported from Taiwan, Japan, Europe. Shows you how interconnected and maybe fragile the whole system is.
And it's not just materials and water. What about the people? The skilled workers. That's got to be another invisible factory.
Oh, absolutely critical. Taiwan has built up this incredible pool of engineering talent over decades, people who really know the ins and outs of running these complex fabs.
You can't just replicate that overnight in Arizona.
No way. There was a real talent gap. Reports said initially, chip yields the number of good chips per wafer just plummeted.
Ouch. So how do they fix that?
Intensive training. They sent hundreds of American technicians over to Taiwan to learn directly. Now, apparently the yields for the 4 millimeter chips are getting comparable, which is good news, but it took a lot of effort.
It really shows how much know-how is involved.
Yeah.
And I heard even once the chips are made in Arizona, they don't always stay there.
That's the packaging bottleneck, another key step for really high-performance chips like some of NVIDIA's GPUs made there.
Yeah.
They currently get sent back to Taiwan for the final advanced packaging, things like stacking multiple chiplets together.
So even made in America might still involve a trip back across the ocean.
For some products, yes, because the U.S. hasn't had enough capacity for that super high-end packaging, though that's something the CHIPS Act is trying to fix.
Let's talk about dependencies. You mentioned lithography lasers. Those machines themselves are incredibly specialized, right?
Totally. The EUV and DUV lithography machines, extreme ultraviolet and deep ultraviolet, are arguably the most complex machines ever built.
And where do they come from?
One company, ASML, in the Netherlands.
Just one company globally makes these essential tools.
For the most advanced chips, yes. Without ASML machines, you basically can't build a modern leading-edge fab. The U.S. imports them from Europe.
That dependency is huge. And it plays right into the geopolitics, doesn't it? The whole U.S.-China tech competition.
Absolutely. Controlling AI chip production is seen as critical, and TSMC makes something like 92% of the world's most advanced chips. That puts them right at the center of it all.
So the U.S. push for domestic substitution is clear, but relying on Dutch machines shows true self-sufficiency is still a long way off.
For everyone, really, China faces similar hurdles with accessing those same ASML machines due to export controls. It's a complex web.
Okay, so given all these challenges, cost, water, talent, supply chains, equipment dependencies, what's the U.S. doing about it? That brings us to the CAPS Act.
Right, the CATS and Science Act. It's a major government initiative designed to tackle exactly these problems.
And it involves a lot of money, I understand.
A lot. It's triggered, they say, over $600 billion in announced private investments across like 28 states since 2020. The goal is to create over 500,000 jobs.
Wow. Is it just focused on building more fabs like TSMC's?
No, and that's the crucial part.
Yeah.
It aims to boost the entire ecosystem. Remember those invisible factories?
Water, materials, tools, people?
Exactly. So there are incentives for making raw materials like polysilicon here, the silicon wafers themselves,
Okay.
for companies that make specialized fab equipment like vacuum pumps or those FOUP pods that carry wafers.
Right, the little carriers.
And importantly, for building advanced packaging facilities domestically. To tackle that bottleneck we discussed, Amcor, SK Hynix, Intel are all investing there.
So the goal is broader resilience, not just chip fabrication itself.
Yeah.
What are the specific targets?
The big one is for the U.S. to produce at least 20% of the world's leading-edge logic chips by 2030.
Up from 0% in 2022.
Yep, a huge jump. And they're trying to create multiple geographic clusters. Arizona's one, but also Ohio, Oregon, Texas.
And I read the government might even take equity stakes in companies getting CHAPS funding.
Yeah, that's being explored. For major recipients like Samsung, TSMC, Intel, the idea is to ensure national security and economic goals are met, giving the government a direct stake. It's more than just handing out grants.
So wrapping this up, this deep dive really shows it's not just about plopping down a factory.
Not at all. It's about building, or maybe rebuilding, those 4 interconnected, invisible factories for water, for specialized materials and air purity, for the incredibly complex tools, and crucially, for the skilled workforce, and knitting together the supply chains for all of them.
The TCHIP Act seems like a serious attempt to orchestrate all that.
It is. Significant progress is being made, investments are flowing, but turning this foothold into a truly resilient, independent powerhouse, that's still a complex dance. Technology, economics, people, it's all got to come together.
A massive ongoing effort. The question is, will it be enough to truly shift the global balance? Definitely something we'll keep watching.
For sure.
Thanks for listening to The Deep Dive.